Hello and welcome to first lecture in 15th chapter of our comprehensive course on AI, ML and DS. Now this is the lecture Introduction to Seaborn for data visualization. Now here, why a new library was required in first place. As such, Matplotlib is pretty powerful, and even its ability to give customized plot also we have seen that if you use that object oriented approach with Fig and AX object creation first, then you can create any complex any complex plot from that. But let's just see the code for that, and you will realize that there should be some easier way of doing the same thing, because that last at the end of that we had plotted one complex, this one. It was entirely done by Matplotlib, of course using that Fig and AX, that is object oriented approach. But you can see the code now. This is a little bit tedious to remember this kind of coding. In the era of AI tools, this has become easier, but at least AI tools have come into existence only from 2002. So before that, it was very difficult to customize using Matplotlib to this fine or granular level. Okay, so then what we have done is we designed, instead of this much level of customization, we designed one library only, which is by default produces better plots and more aesthetic plots by default, and it is not designed from scratch. It is based on Matplotlib only. So in a way, Seaborn is just constructed over Matplotlib, but it provides a high level interface for drawing attractive and informative statistical graphics. This word statistical is important, because the data science point of view, we are always interested in a plotting library which has built-in functions for statistical graphics. For example, there when we needed to that sophisticated plot which I just now talked about, I closed it, but you remember that we needed to show the percentage increase in the sales. Then that was the way to code it was very difficult. But if there is a built-in function for percentage change, for showing standard deviation, for maybe other variance and other things, so then it might be very helpful for data scientists. So Matplotlib was a general purpose plotting library, but this is more specialized for data science and machine learning engineers. Okay, so what are the key advantages of this Matplotlib library? So one is statistical plotting. It includes built-in function for common statistical plots, making it easier to generate complex visualizations like heat map, violin plot, and pair plots. Then second, it has better aesthetics by default. So in Matplotlib also you can get any highly sophisticated aesthetic, but you have to explicitly code each and every detail. Now that some expert coders prefer that, because they think that enables them complete control. Okay, that is granular control of how to modify each and every aspect of a plot. But intermediate level programmers, and most of the data scientists are usually not expert programmers, they are intermediate level programmers, so they may prefer something which out of the box gives better aesthetics and does not require much customization using code. So that requirement is satisfied by Seaborn. Syntax of Seaborn is very simple. For example, it eliminates the need to specify that figure and fig size and all that. You can straightway start plotting the graph. So that is one thing. Integration with pandas. Now that is also important. Backward integration is always must in software, because on one side you are designing a new library, but you cannot say that my library will not work with the pandas. So create now a new data manipulation library which is similar to pandas in functionality, and which should work with Seaborn. Now that way things are not done, because pandas had become so popular by that time. So anything which is developed, that should integrate well with pandas. And there are some themes also, so one can quickly change the visual appearance of the plot by using those built-in themes. So if the boss asks that, no, I want this background or I want this color palette instead of what you have used, then you don't have to change the code much. You just have to change the theme which you have used. Okay. Now here we want to do the data frame creation. Now for demonstration, let us create a data frame which is suitable for showcasing some of the Seaborn's capacity. So synthetic data frame, it has age, income, and gender, 3 columns. So say a simple data science problem is there, that we are trying to predict income based on age and gender. So that means we want to see that if age has something to do with income of the person, and gender has something to do with the income of the person, and if yes, if income does depend on this or both, then how does it depend? So simple data science problem is given to you. Now, first of all, before you move ahead and start building model and everything, you have to first see that whether your sample is representative enough or not. That means whether your data distribution is somewhat nearer to the Gaussian distribution or normal distribution. That is the first thing to check. Okay, so our standard method steps, whatever were there for matplotlib, same steps are there for Seaborn also, except there is only one step change. That is one, that figure size and fixed size and figure. That step is not required. You just straightway start creating the plot. And second thing is SNS word, that is the alias for the Seaborn library. That is required only for one step. That is when you specify the type of the plot. Okay, but once that step is done, still it is always in all other steps, title, X label, Y label, legend, grid, everything that we do by our usual method only, PLT. That is the meaning of that this sentence, that it is a library which is built on the top of matplotlib. So that was done by purpose, so that there are no big changes in the code required. You just have to change one line. Instead of plt.histplot, you can write sns.histplot. So this is my data frame, and I want to plot a histogram of age versus the first histogram of age, say univariate analysis. And so I write sns.histplot and df age, okay, and KDE is equal to true. That means I will get this kind of kernel distribution. So that will show me roughly how close my data distribution is to the normal data frame. And color, okay, let me first clear that so that you can be assured that it is working. And now you can see this. What this has done is, you should understand why we are doing this even before creating model or everything. This ensures that whether my sample is representative enough or not. So yes, it is representative enough. It is 20 to 70 years of entire range is covered, and more or less you can say that in every bin of age 20 to 30, maybe 30 to 40, 40 to 50, every bin there are more or less equal number of observations. Of course, there are many senior citizens, and here in this bin 40 to 50 bin there are very few. But in general, you can say that at least there, it is not that there are zero members in this age group, and there are maybe hundreds and hundreds of members in some other age group. Not like that. That frequency varies from 2 to 12, which is a reasonable variation. And age is varying from 20 to 70. So almost the working age of human beings is properly covered. So that means my age column is, in short, having the proper distribution, or it is a sample which is giving proper representation of age variable. Same you can think about. Otherwise, if, see, try to understand, if my data frame, this is head only, but if I write entire data frame, now if my entire data frame, that is all 50 rows, if of age 22, 23, 24, 23, 22, 24, 23, 24, like that, then what is the point of doing that kind of data analysis? Because I told you that I want to understand what is the effect on income of age and gender. But for that, my sample must be of representative, proper representative nature, so that it represents all age groups and not just 20 to 25 age group, right? Similarly, about gender also, I can plot the same plot with df gender. Here it is not plotted, but I can just say copy paste this much, and here instead of df age, I write df gender. I want to check that whether I have included the male female in roughly equal kind of proportion. And okay, so if my sample again contains only males, then how will I study the effect of gender on income, correct? So these kind of plots are used for that purpose. So if I plot, now I see that female and male both are relatively in equal proportion. Around 22 females are there, and around 28 males are there. So yes, my data is good enough to study effect of age and gender on income. So that is the requirement of plotting, and SNS clearly is very easy, and very nice and aesthetic plots are generated. And color and all the background and everything, it adjusts more or less on its own. Okay, so that is one thing. Now create another data frame. So this is that data frame. It is a data frame which contains 3 columns: month column, sales column, and profit column. Okay, and we want to plot a graph of sales versus profit. Now you will be surprised that why sales versus profit, but I tell you one very interesting use case where the sales versus profit graph is required. And I want suppose a line chart or scatter plot. Yeah, scatter plot, then SNS dot scatter plot. Otherwise the steps remain same. No need to specify figure and fixed size. So directly start plotting SNS dot scatter plot. And scatter plot is always of 2 variables. So I will write df sales on, say, x axis suppose, and df profit on y axis, like that. And color I can specify. Maybe if I want the dot type, then instead of oval or circle, I can specify other type for the marker. Okay, so that is the scatter plot. And why this line is appearing? Yeah, I wanted to show the difference between how to do by PLT and how to do by this SNS. So with SNS, the syntax is SNS dot scatter plot, and with matplotlib, the syntax is PLT dot scatter. Otherwise, the rest of the things remain same. You have to specify X, which column of your data frame creates X, Instead of that, it can be simple a list also of sales of various months. And y, so which column you want to take as a y variable, and then you have to specify color, and if you want to specify, then you have to specify marker. Okay, now let us first plot using SNS and see this kind of case. So, and you can see SNS creates a fine dot, and the scale is very fine, means slightly smaller dot, and scale varies from 200 to 320. Now what I do is I just comment out that SNS line, and this line, that is PLT dot scatter, this comment I have removed. So now I am plotting the same scatter plot with using PLT, my matplotlib. Okay, not Seaborn but matplotlib. With Seaborn I got 200 to 320 range and this kind of small dots. Okay, now with matplotlib I get slightly bigger plots, but otherwise here you hardly notice any difference. Again 200 to 320 range. So here this does not display the real power of SNS, that is clear. Okay, you could have used matplotlib also, but chapter is about the introduction to Seaborn library, so therefore Seaborn. Okay, and remember this, that for matplotlib it is plt dot scatter, for Seaborn it is SNS dot scatter plot. Okay, here also it was hist plot. Okay, here hist plot, so scatter plot. So sometimes the syntax varies slightly depending upon whether you are using matplotlib or whether you are using Seaborn. Correct. Now, what is the usefulness of this kind of graph that I was taking? Because that is interesting. Say profit versus sales. Now it looks like that, okay, means whenever sales increases, profit increases. No, we are missing one very important metric of the business, that is called margin. Margin, if margin is constant, that is say 10% margin or 15% margin is there, that means on every sale, 100 rupee sale, 15 rupees is the profit. And if that remains constant over this whole region, then I can say yes, when sale increases, profit increases, and everything is normal. But sometimes what happens is a business is passing through the tough time, and at that time, or maybe a new competitor with a much better product has jumped into the market, and you want to clear your old inventory very fast so that you can also launch a better and competitor product. So at that time, businesses do what? Of course, they are listed on stock market. So if their sales suddenly drops by say 50%, then the stock price will also drop. But what you can do is you can reduce their sales by maybe, sorry, what they do is they reduce their margin. So they start selling the same product with only 5% margin. Now what will happen? Sales will keep on increasing. In fact, it is possible that compared to earlier years, the sales increases very rapidly because the old product is now available. They are compromising with their margins, and they are taking only 5 rupees profit for 100 rupees of sale. But will their profit grow at the same, this kind of linear rate? Then it will not grow at that time. Earlier, suppose here this was the region where 15% margin was there, while here this is the region where 5% margin was there. So at that time the profit would actually go down. Sales is increasing, but the profit would actually go down. Okay, so many stock market listed companies do this kind of what you can say clever accounting. And if you are a stock investor and if you just go on looking at the sales, then you will have an issue because you are looking and yes, sales is increasing. But if you plot this kind of graph, that profit versus sales, and if it shows this kind of movement, that yes, profit is increasing in sync with the sales, so then you can say that yes, company is selling more and more and still it is maintaining or protecting its margin, so profit is also increasing more and more. Okay, so that is one nice use case of this kind of profit versus sales plot. Okay, now in next lecture we will do about this distribution plot and town plot. Okay, so see you then. Bye.